Today's date is the 4th of February 2026. The time now is 6:31 a.m. Um, I'm not doing the report today. I'm working on this report. So let's get started. Yeah. This repository, this video, uh, this video primarily. This video is for Rift. Rift stands for Rift is a flexible translator. Rift is a flexible translator. We're going to be focusing on two big things. We're going to be focusing on Rift as the UI UX library, or UI UX. So the problem that Rift has is literally Rift is a Rift is by natural. Um, R colon R matrices. You have a root syntax. I'll be demonstrating C code and C code, but we're gonna focus on UI UX for using REST bridge. REST bridge. So the goal is to have a system of native apps written in Rift. Now, Rift is a compiler toolchain. It's a compiler tool, primarily a compiler toolchain, and primarily an app system. You can write web applications in Rift, but the goal I'm trying to show you how to develop Rift component in isolation because it is separated by concern. Rift is an application system that's separated by concern. For example, Rift has a Lapis integral model. You have an axis of 0, 0, 0, and you can both have 0, 0, 0, 1, 1, 1, 2, 2, 2. So, on the board, I'm going to create a grid of the system. I'm talking about. I'm going to talk about the folder architecture model. So, this is a UI UX philosophy for packaging wireframe components into a exportable executable program. It's basically a link and executable format. So this is a link and executable format or a link then execute. This philosophy is bound to ref based on the system of equipment. So what this video said is you got executable and linkable artifacts, and you have linkable and then executable artifacts. The polarity, if you link the flag for this can be Rift uh, dash L, dash L, capital L, dash capital L, path to lib, path forward slash, to forward slash, lib, rift, path to lib, um, um, and then the directories, the library name, such as the star.sl. Star.sl prevents linking all shared object libraries in a Rift machine ecosystem. The shared libraries are equal to one of those dynamic libraries for the container system. So this can be lib containers in isolation, containers of organization from because the containers are portable are the things that contain all the artifacts to build for a system. That's what containers are. Docker containers are normally containers they build for a target of a system, and the target of the system for the system. So Rift ensures this works because it's interdependent. So the Rift interdependency model is what I want to speak about today of linkable, 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 L, linkable, LTE, linkable to executable format. The linkable to executable format, or LTE flag, is basically linked then execute. But we have executable to linkable executable linkable format. Executable linkable format is for programs, executable programs, and also the shell programs, command line programs, or terminal programs. But they are executed first. So they start with the program. Then the program start. This linkable starts with the linkable, looks for a library first, or a container, or target operating system. So I'm trying to create a tomographic system that resolves this system. So you get the rift you get the lift, you get the rift Lapis mapping. So you have three vectors here. So the three vectors written this in Lapis mode. Alpha llama, alpha llama, alpha lamb, alpha lamb, or alpha language. A for apple, P for papa, I for indigo, S for Sarah. So this represents Lapis. So you can have, to make an example of this is, you can have two on the x-axis. You measure two, 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 one, one. This 211 is has text. So this 211 on the x-axis means you have let's say 212, 212. You have the number 212. This 212 has the equivalent of -2, -1, and 2, -2. Yeah. So we're trying to compute this model state. This is a package system. The using left hand edges, you can have 212. Right in this in the endiness. For example, this is basically if you have 000, we have an artifact that's ready. But you have a 3 by 3 matrix, 3 by 3 matrix, which is basically the standard of 000 and 000 is equivalent to epsilon. Is equivalent to epsilon, epsilon, epsilon. And we have which is nothing. What is loaded? No. This is an epsilon state for system based on observer pattern. Observe what the pattern what was really index. But this tomographic was the accuracy model of growth. So you have the downloader and the folder hierarchy. But 000 equals EEE, which is epsilon. And this EEE is equal to another 000 or another 111 -1 equal to -1 -1 when nothing is installed. Nothing is stored. And nothing is stored is another state of the program, another stale state. So you have a consensus of -111 equal to 0, equal to 000. You don't have a maybe here. You have things that resolve. You get a maybe system does it for you, which is basically a maybe parsing, treating of a consensus. But you get consensus here as well. So you get maybe too, because you have to have maybe to resolve arbitrary conversations of system resolution of registries. So the risk basically has to download artifacts. You just reach them to 0. So 0 represents in left 0 represents a token stage. So you get a token stage, a token pipeline, and a token stage. A token pipeline. Yeah, no, 0, 1. So you have a token stage, a token pipeline. So you have, for example, so the number 1 on the far right represents a token, 0 represents no token stage, 000 or epsilon hold negative or 000 hold epsilon, which holds -111, which have not downloaded the artifact. With a consensus system, this basically turns as you develop more code, hold the space you hold it with -1. I'll come to that. So you have this model here. Let me show you on screen right now. Because you can see it right now. Well, the time will not work. So as you can see here, As you can see here, you see there is writing on the board, but you're going to have 000 become 111 and 222. So these are the stage tokenizer stage. Tokenizer stage is a one. Tokenizer stage and the two represents the parser stage. So the sequence of one represents a tokenizer that is stage one of unit testing. Stage two is integration tokenizer. So you have a system of stage bound execution order based on tokenizer to parser. But it's an interdependent system. You feel like it's an interdependent system. You have to decouple order system of stage. So you have stage. Stage is basically the stage is on. The current process is on. You have a pipeline. So you have a stage and you have a pipeline, which is the order of the system. For example, so you have a token stage. So the token stage is like 111. The C library on Rift uses an R syntax, R matching to match artifacts of shared libraries. If they compile using linkable stable, you get 111 with stage pipeline 111. So you get a pipeline, which is the coupling of stages. So you get one stage, you get a tokenizer to a parser. But the tokenizer is one stage and the parser is another stage. But this is a pipeline together. So you can have stage 2, 1, 2, 1, 2, 1, 2, 1. 2, 1 represents, or 0, 2, 1 represent an artifact that is 021 represents an artifact that is a parser. So you have 01, which represents a working a 011, which 010 represents a lexical analyzer or part of the written ref, which is a matching system. Written ref. This tomographic system matches basically what's the polar axis using Lapis calculus. Now, Lapis calculus works um, by ensuring that there is no that everything is cast the cutoff point. For from point A to B, is the midway point is AB, and that is the start and stop of downloading new artifacts, loading new linkable artifacts. So the artifact doesn't really explore linkable and stable, but the artifacts are dynamic. They kind of cutoff point, which is half five. At 90 degrees or 00, the value stop at 00. And this become linkable, not executable. And then you can change, you can then link them together to have executable construct. So I'm saying to you, we're going to have a system of interdependency. So you have things work as a circular amount in a lattice manner. Then we get pi over 4, which is node squared. Now, node squared represents node cubed, node times node times node, or node to the power of 3, node to the power of 3, or node times node is basically node times node, node squared. Now, node squared represents the area of the system, but node cubed has been mapped into a system. So, the goal of this video is to show this system is coherent based on Lapis principles. But we are thinking and probing. So we get a tomographic mapper that a stage bound, which is 0, 1, 0, 0. You have a 001, which is a valid working, a 001, which is working lexical, and 002, which is basically a schema for something that's parsing in ref. But this is basically not, this is basically universal, this is linkable, so it can be a program or a library that is a UI UX library. Then you have 0, 1, 0. Now 010 is the system has the main function for refresh. So you have two ways to look at this. You can have 010, which is just one stage of a system. Now 010 represents one system. Maybe the unified system, you basically just see one C system. One system, it's a monocle system. So it's one system like C app, C sharp, C plus plus app, or C plus plus app, or C sharp app. So this stage represents two things. It represents hold on, choke. It represents two things. Sorry, guys, let me just get my chalk. So you get on my pencil. One second, guys. So it's not a good idea to not have my pen on me, but I'll find show you the idea. So, for example, the framework works by this. So you have the 2 pi to 1, 2 pi to the ratio of 1. Now, 2 pi to 1 represents an area of 2 pi. So 2 pi r, where r is a unit, r is 1, equal to 1, a complete working artifact. So 2 pi r, 2 pi to the range of 1 to 1, 2 pi implies 1, or explicit 1. So 2 pi is a rock, is a cutoff point, is a cutoff between something that's working as a lexical analyzer. And the lexer has a stage 1, 1 in the x-axis, 1 in the 1 in the lexical analysis. 1 in the lexer analysis. But this one is this 001 is basically a working lexer, which is a ref. But this working system can be is basically a stage bound, a process bound. Yes, a process. So you have a working process or a process which is a process which is linkable, then executable, or executable, then linkable. This represents just a lexer process or procedure, which is a lexer process or procedure, which is basically means it's executable. It's executable. It's a one-way form. It's only like a lexer that is a library, like a C library, like a shared object library, or a .a static library, or a dylib for Macintosh, or DLL for Windows. DLL. These artifacts are crucial to understand what the system is linkable, then accessible, and executable, then linkable. You know what I'm saying? Depending on the plurality of the bipolar nature, the bipolar nature of the access, determine how the system handles image files, and loads up target programs based on what the artifact is, what the order sequence is, what's loaded first, the library order system via context switching. So 001 is a standard lexer, but 001 has an access of lexer. So you have 001, but you have you have 001 and 011. Now you have the same matrix, as you can see here. You have 000, and you have 011. But in this stage, you have minus epsilon, epsilon, which is 00, 00 times 1 times 1 times 1. So you get 2 epsilon 00 on the x-axis. This is an x-axis, and this x represents a stage bound process and procedure. So this is process and procedure. Now, process refer to the processing on the board here refers to a resolution of an artifact that is on the fly, that's being downloaded, that's being executed while either executed while it's being operated on, or going via schema, previous schema. But the process can mean on the fly execution. On the fly execution. These are loading and downloading. That can recover downloading state, recover tomographic state. So that's what process means. So you have a probing system. So probing is how the system. So the tomography system has probing too. So you have a peer to. So you have a remote server and a local registry of the Rift tomographic system. The goal is to have two main ways to do it. So if you have a peer-to-peer, you have a third one that a third process that they share consensus over, which is a peer-to-peer model, which was similar to doing. It's a trillion peer-to-peer network. A trillion peer-to-peer network. So, example, remove condition server, and then remove and then consensus from and then remove to server, and then shares a probing a probe. So probing usually solve problems as well. But probing is like the idea of thinking. So you are on the fly processing, but the system is like resolving new tasks given to you ahead of time. For the UI system. This is reaching 20 minutes. 20 minutes. So you have 001, and you have 001, but this one is on the x-axis. So you have to match one and one. So this will be a reference stage. One and one will be one and one. They align at one. So you're looking for alignment. Alignment. So this is an alignment operator. So you have one and one. But this one comes from zero here, one here on the x-axis. So on the x-axis represents the process and the processing and the procedure. And one more thing, the tokenizer stage. Tokenizer of the tokenizer stage took another stage. And you get the other one. So you get 011, you get 0, 0, 212, 212, 21. So 212 basically represents stage bound tokenizer of stage 0, 2 of stage 2, which is parser stage. 212, parser completed, which will be packaged. And then you get one, which means the tokenizer is ready. So 2.1 represents a complete parser, a complete parser when it's on the a complete parser when it's on the y axis. So you have a 212 on the x axis. It doesn't mean anything. You have to have a 212 on the oh sorry, if you have a 1011, if you have a 01, you have to have so if you have 011, 001, you have on the y-axis, which represents the y stage or the integration stage. So you have x, y, you have minus x, but x represents unit models like modules like C files, module files, and these are x's basically on you have integration tests which work on the y-axis. So you get x, y, z. So the goal is to have a system that's tomographic. So you get a system that resolves itself from 2 pi out to 1. And 1 is the radius. 1 equals r equals 1, or the radius, or the full rate. R equals a full unit of 1. And then you have the 2 pi, 1 over 2 pi. So 1 over 2 pi is basically 1 divided by pi times 2, which is 0.6 336. But you have 2 pi over 180. Now 180, 2 pi over 180 is basically 2 times pi is 36.22386. Two pi, 2 times pi divided by 180 will give me the angle radian. Now, this will give me radian 0.314, but this is one full path of pi times r times r times 100, 100, 100. Now 100%, 100% of the system, which is 3.498, 498, 3.490, that's 2 pi over 180 times 100. Now 100 is the fourth percentile of the system. Now we're going to divide by we're going to times uh, uh, basically this represents 2 pi over 180 is 0.3496. But basically times 100 makes it this makes it the angle in radians. So 2 pi 2 times pi, 2 times pi, 2 times pi is 3.3.283, 6.3 times 2 times pi. No, 2 times pi is 6.28. And 2 to make it divided by 180 will give it divided by 180 will give me in radians, which is 0.3 radians. So this is 2 pi over 180 in radians. 2 pi. Now you get 1 over 180, which is 180. So you get the unit of systems. You get some. So this basically over 180, which is the pathway. Now the pathway between 180 is basically 2 pi, which is the parameter over 180, which is the unit of 180. They have to times by 90 degrees. Now 90 degrees is basically times 90 degrees times 90 times pi. So sometimes 90 degrees times 90. 90 degrees. Let me calculate 90 degrees uh 90 degrees in radians, which is equal to times no so 2 times pi divided by 2 times pi divided by 180 degrees 180 degrees times times 1.5707, which is 90 degrees, will give me in radians, will give me 0.5. But 0.5 is tomographic. So let's resolve the system of 0 to 1. So basically, this ratio stays between 0 and 1 for the resolution of the system. So that's the first part of it. So as you can see, this is a valid welcome proof of work concept. So because if you do your calculator, it does work as intended. Hope I've not closed this thing down. So basically, I have got the solution 0.054831, and that's basically 2 pi over 180 degrees, which is in radians, which is basically 0.034, and then we have times 90, not 180, times 90, which is halfway, 0.5. This is where the interdependence kicks in. You get the ratio 0.054311 or 0.548 548. So that's how that works. So you always say between 0 and 1, and you can get the mapping of the stages. So the mapping is basically working XYZ, and X equals equal is very important. So if you have 1 on a dimension called X, this X is a dimension, not a value, and you have three number 1 to 1. Number has to be from 1 to 2 pi to go to be so you have 0, 0, 1, 0, 0, 1, 0, 0, 1. This 0, 0, 1 represents intermediate state of the kind of value here we have. Which is uh, 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 0.05 uh, uh, system. But we have to times it by 2 to have, so we're going to have 2 times pi over 180, divided by 180 times 2.5 over 180 times r squared times radius, and the radius is basically 1, but you have to do times the radius, which is 1. But this 2.180 times 4 times 4. So you have to make this number become 1. So basically, I have to put algorithm. So basically, if I put times 260 times 260, I should get back the times 260 in radian. I should get back the full artifact of the system, which is the first quadrant. So the first quadrant is 180. The second one is um, uh, uh, 360, 360, 360, and that's basically 6.28 or 3.1, which is 360. But I will do 270, which is the third quadrant. So you have this in third quadrant. So the third quadrant of 270 would have number 3. So number 3 will be there. 311 or 003 will be the encoding for the third quadrant. Times 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 4.7123 9, which is in radians, which is 270 degrees in radians, which equal 0.1644. But it's not yet 1. It's not yet 1. So you have to go to 360 in degrees to have a 4, which is 6.2, to have a 1. And this will basically make sure that 2 pi rotations is 1 over 360. So you have 720. So it's a safe protocol for showing that the solar system maps isomorphically to the system of 2 pi to 1, 2 pi to 1 mapping, or 1 to 2 pi. So if you're going to have a consensus model, which is basically determine the power that the system holds to compute, first of all, 0, 0, 0, 0, 0, 1, 0, 2, 1, which can mean the tokenizer, basically, can use right-handed code. You can use right-handed right. But if it's right bitwise, you have 0, which is basically the tokenizer it's not been built. There's no tokenizer. There's no tokenizer. This is right. You have to go to you have 0, 1, 2, 1, which is left-handed. So you get 0, 2, 1. So you get a tokenizer of stage one, which is a process and a procedure of a linkable executable format, and then executable linkable format, which is a program that can do a process of procedure, and 0, and you get 022, which is a Alexa that's a parser. So you have a linkable executable parser. You get 023 on the axis of x. So 021, 022, and 023 is basically the abstract abstract. So 123 represents the coding of abstract and abstract 3. The coding 000 are shared, 0222 are shared, and 0123 are not shared, but they're distant. They're different stages. So stage 0, stage 0, 1, 2, 3, 4, 5, represent different stages. Now, stage 3 is what the linkable simple file was really doing. So we can speak about stage 3 a bit more before the video ends. So stage 3 works by this. So you have a hierarchical file. You get a file like image assets such as sounds, and then you assets folders. To get a root folder, you get a subfolder called images, and you have a file called source, and you have a source slash c, which basically you have a source slash c plus plus cpp. I have a source slash src slash C sharp. Now, these files are targeted to target have targets. You have build slash target target build slash target target lib build slash target lib. This target lib is really directory of system because this is the contain system here. So you got the images file in one folder, and the images are here. We have in the source folders you have a main.c, a main.cpp, and a main.c sharp. C sharp. But you don't have to build all of them at once. Usually you just build one app, and the one app will be rebranded based on the targets you're building for. Because you have to be a sparse, powerful model. So the goal is to have Rift match tokens via a token triplet of token type, token value, and token type, token value, and a shared token kind. Now, the token kind is for UI UX, which matches engineer systems and the tomography mapper. So you have token type, token value, and token type, token type, token value, and token kind. We have token type, token value, and token kind, which is basically the kind of tomographic mapper, which as is token kind, token value, token kind, and you have token type, token, and token memory, the memory of the token shared over C matchup. So Rift is a function because you get the artefacts, you get to match tokens via templates. So the templates allows you to match patterns across placeholders. So you have the backtick. The backtick is what we're doing on. So you get you see R speech mark, and you have R backtick. Now, backtick forward tick is basically the key that determines if you R backtick A to Z um, colon A to Z colon colon star. It uses so no, that's the wrong one. Question equals star. Eight. So you have a registration in the wildcard system. For example, you have backtick, which is a placeholder. So if I'm trying to match dot uh, uh, JPEG star dot. If I'm trying to mark star the PNG and start the JPEG, start the PNG. I just put star.png here into the matching of the double quote. Now, the double quote star.png it shows has a mapping to find a star where star is a wildcard. Now the star wildcard represents any file that is an image, any part of the file in the local directory that's an image. Now you can have star forward slash star.png, which basically subfolders in this directory, wherever the root is defined. Now, this is star matching PNG images. If you put colon or square bracket dot jpg, so you have slash star dot curly bracket png or dot j or comma jpeg colon bracket. So you have like this in speech marks. Now this will start looking for all the files via the wildcard, but oh no, via the backtick placeholder. So in the placeholder, the placeholder has a real-time nexus search. So this works by a self-balancing nexus search filter. When you go to github.com /n for November, E for Echo, S for X-ray, U for Umbrella, S for Sarah, dash S for search, nexus dash search, you find that this works on three node execution of the one wildcard, one star represents a series of executions such as a series of like R, capital R, backtick, square bracket A to Z, sorry, so you get R question R curly bracket question equals star, but the star is basically in another curly bracket. So you get R backtick, backslash, no, backtick, and then which between placeholder matching system that matches a star PNG. When R so you get R backtick. So the backtick is used for the placeholder to match all the wildcards. So this is basically for UI US like middleware regular expressions that work on the next search philosophy. Now, basically, it's defined as so. You have this defined as this. You have message search working like this. So message search works by matching by matching characters of systems. So if the star represents all the characters that the input gets, you have A to Z, A to Z, A to Z. But they use breadth first search to match a layer, match a layer, and that layer is basically where the word is. So if you have the word apple, you have APPLPLE. So apple has a root node. The right node is left. Right node is left node is P. Left node is P. The right node is left node. The left node is P. The right node is P again. So left and right. Left node is L, and the right node is L, and the last left node is A. Left node is E. And this is the correct. So the bottom of first search shows that this system shows that you are searching breadth first search. So the breadth first search of the first is basically matching anything that is stated as a wildcard of A. So for example, if you have the expression R R colon R backtick question equals star. The question mark equals a star. In brackets, you have to match all the brackets in the first term, and the backtick on bracket you have the flow by the registration A to Z, lowercase a to lowercase a to z, and 0 to 9. You'll be locked into match him, and then you close square bracket. And then you close the square bracket and close the expression within the square bracket. Now within square bracket, you have R again. So you have and then you have the square bracket because of the back tick. You have and so, so when the wildcards encountered, it goes to look for the root node, which is a star. Now the star basically points to a system of where of middleware. So this star or this star, it is a star to be looking for a folder. Well, it's looking for files with a text name, that has any all these characters to them to it. But this has to stop at someone. So 0 to 9 A to Z dot star dot so this will basically match anything that has a text, any long file name that contains letters and numbers, but whenever there's the input is a star, and once you look off, so you will match Apple APPLE and APPL without the spaces, without the spaces. If I put without any word boundaries or without um, uh, with backslash b, which is any word boundaries, which is backslash b. So this version will work like that. So this star, you get the star. So if you have the R speech mark star forward slash star, this slash is a folder, given a slash, a folder slash, because the slash will put the append, put the folder slash file name dot jpg will match all the folders of the system of the ecosystem. Okay. Thank you for those video. That's how the Tomographic mapper works, and that's how the system works in Rift. Hope you liked it. Like, share, subscribe if you want. If you don't want, I don't really care. Thank you.